So here's a quick video on using the graphing calculator in kind of a basic way to find values of functions. So if we're graphing a function, that means we have an input-output relationship. And so the calculator reads that as y as the output and x as the input. So y is kind of a stand-in for our f of x, and x stands in for x. So let's look at number 26. Use your calculator to graph that the function g of x equals 7 minus x over 2 in the standard window. Okay, so the window is important. It's how we view the graph. And then the input-output relationship is what comes in here for the plot. So y equals, which means g of x equals, the output equals, this rule based on the input. So 7 minus x divided by 2. So this matches. So we know we're good here. We're going to check our window. This is the standard window from negative 10 to 10 on the input scale and then on the output scale. So my outputs are from negative 10 to 10 as well. And then we can go to my graph. And we see that this is the graph of the line that cuts across the screen. Here are my x and y axes. And now we're asked to find g of negative 3.2, g of 1.8, and g of negative 9.8. Which again, what does this mean? This means what is the output value at an input value of negative 3.2? What is the output value when we have an input of 1.8? And the same for the last one here. What is the output at an input of negative 9.8? So we come across on the input axis and find what's the output, right? We tilt our head up and down to see what's the height of the graph to find that output. So at negative 3.2, one thing we could do is use the trace function. And so if you use trace, it should pop up on the curve that you have plotted. Here's your y1, here's the equation of it. And you can now input, using the keypad, the x value, and it will spit out the y value, which we know is a stand-in for g of x. So we'll say negative 3.2, enter. And this says that the y is at a height of 8.6. And so again, that represents what the output value of g of negative 3.2 is. So yes, the height of the curve is 8.6, and also the output of this function is 8.6. So the same for 1.8. X equals 1.8. You see it popping up here. That's a little bit closer to 2, so we'd expect, okay, along the input axis, I'm right here, and then we draw an invisible line up to where it crosses our graph, and it crosses at a height of 6.1, and so that's the output here. And then lastly, negative 9.8 is a height of 11.9, so that's coming out here. Negative 9.8, you can see, is pretty far to the left. If this is a input axis of negative 10 to 10, that means I'm really right on the edge of this window. And we got kind of lucky that the graphing calculator gave us this value, since we're technically, the output is drawn outside of this window. Oftentimes it will give us a hiccup here. So if that is an issue, two things you could do. The quick and dirty way is to zoom out once. So you come to zoom and then zoom out. And then you have to hit enter again. And it will go based on where your trace is. So at negative, oops. Still have to go back to trace. So at negative 9.8, we're at 11.9. And now we see, since we're zoomed out, the graph is more contained in the window. So that's a quick and dirty way. The other way, again, to come back to the Z standard, is zoom 6 to get negative 10 to 10, negative 10 to 10. Would be to just set the window a little bit wider. So we might come to negative 15 and then have my Y max go up to 15 and see if that helps anything. See how I opened up kind of the left-hand side of the window, and now I go again, negative 9.8. Boom, 11.9. So now we can see it because it was kind of up here in the corner. So I hope that helps with this kind of basic functionality and again, mapping the inputs to the outputs. And if something's not showing up, most likely what you got to do is play with the window. Don't be too excited about what this notation means. Again, this is just your input minimum, input maximum, input minimum, or output minimum, output maximum. So short and dirty way is left and right sides, and then bottom and top. And so the more you zoom in, the probably less you're going to see, and the more you zoom out, the more you're going to see, but it might be too crunched to make any sense of it. So you got to use the window wisely. Okay, I hope that's helpful.